So what this says, right, is that your genetics doesn't completely determine who you are. The environment around you shapes the packaging material of your DNA and directs, to some extent, how your DNA is going to work. So that already tells us that we are indeed more than our genes. So maybe the question we really need to ask is, are we more than our biology, right? Are we more than the material things, genes or otherwise, that make up our bodies? As a biologist, I've learned at least 3 major lessons that I'd like to share with you today that I think help provide a framework for exploring that important question. First, biological science is very rarely about proof. Rather, it's more about accumulating evidence toward a reasonable or likely or compelling explanation. You know, in theoretical mathematics, one deals with derivations and hard rules and proofs. In contrast, in the biological sciences, one is usually collecting diverse kinds of data and making inferences. Now don't get me wrong, there's certainly a logic that guides your inferences, but it's often more imprecise than people realize. Science is, it's actually a lot like detective work. And in fact, that's what I find so fun about the research that me and my lab do. I mean, think of what a detective does. Right? He or she is faced with a crime and essentially has to reconstruct the course of events that led to the crime. Obviously, often there are many possibilities, and so the job of the detective is to gather information and make a case for the most likely possibility. Oftentimes, the case is so strong that it feels like a proof to me and you. But it's not really. It's just a far more compelling scenario than any other possible explanation. It's sometimes the same way in biology. As a scientist, I'm faced with a particular unexplained biological phenomenon and essentially have to uncover the hidden mechanisms by which it occurs. So this is a lot more like messy detective work than it is like proving theorems in theoretical mathematics. And so that brings me to the second lesson that I've learned, and that is that biological science is constantly self-correcting, and it almost never closes the door on a possibility, even if it happens to defy present assumptions. A prominent example in my field is the concept of junk DNA. Many of you may have even heard about this. Prior to the genome era, the prevailing wisdom among many scientists was that substantive portions of the genome were likely non-functional. That's why they were sort of given the name junk, or nonsense. Later on, many of the same scientists eventually produced the evidence that demonstrated that this was wrong. My point here is no matter how tightly held the view of junk DNA was at one point, there was still an openness in the scientific community to the possibility that it wasn't junk. And it was ultimately this openness that led to new evidence, the dismantling of the misconceptions, and scientific advancement. It's for this reason that you will very rarely see universal negatives issued in biology. I mean, even the vocal atheist Richard Dawkins accepted that as a scientist, he must concede that there could be something incredibly grand and incomprehensible and beyond our present understanding. Now, I don't want to misrepresent Richard's position here. He certainly doesn't believe in a higher power. But my point here is that as a scientist, he is compelled to concede the possibility, however unlikely he may ultimately believe that to be. Finally, the third lesson is that some questions that have arisen from work in genetics cannot be addressed by tools in genetics or biology. For example, at some point during the study of genetics, the question often arises, why did life forms originate in the first place? And it's a natural question to ask, and we're free to speculate, but science is not really equipped to answer that question. And using science to answer questions like these sometimes feels like using colors to describe numbers. I mean, I think you'll agree that color, though by itself is meaningful, is not at all a meaningful construct to understand numbers. So while work in science might naturally lead us to ask such questions, it's evident that science does not always have a clear answer, or even the toolkit to approach the answer. I want to make a critical point here. This doesn't mean that there is an answer somewhere else. It just means that we have to be faithful to what science is, and we can't extend the purview of science beyond what it is capable of addressing. So how do these lessons inform the pursuit of the answer to the question, are we more than our biology? I believe that they liberate us from shackles and the commonly held and often propagated view that science categorically disproves the supernatural, or even that science is the sole arbiter of truth. In fact, science is necessarily agnostic with respect to anything outside of the natural realm. It neither accepts it, nor can it refute it. So the important point here is that science does not constrain us to look only to science in our search for identity.